The surnames of 40 children in a class were arranged in alphabetical order. 16 of the surnames begins with O. 9 of the surnames begin with A. 14 of the letters of the alphabet do not appear as the first letter of a surname. What is the probability that the surname of a child picked at random from the class begins with letter O or letter A? Now, objective of the question. The question is testing the knowledge of probability. That is the mutually exclusive events of probability. Now, what is probability? Probability is the number of expected outcomes over total number of outcomes. Now, from the question, the total number of outcomes is 40, which is the total number of the children, because we are told that the surname of 40 children in the class, that is 40 is the total. The total number of outcomes is 40. Now, we are also asked that the number of students surnames that begins with O. The number of surnames that begins with O from the question is 16. Now, the number of surnames that begins with A is 9 from the question. Now, the probability of a surname that begins with O is equal to 16 over 40. That is total number of expected outcomes. So, total number of surnames that begins with O is 16 over total number of outcomes. So it becomes 16 over 40. Now the probability of surnames that begins with A, and A is 9 surnames begin with A, we can now say 9 over 40. So the probability of the surname that begins with either A or O, which is mutually exclusive, that is independent event, either A or O, will now be equal to the probability of surnames that begin with O, which is 16 over 40, plus the probability of surnames that begin with A, which is 9 over 40. We use plus here because it's a mutually exclusive event, independent event, that is either this or this. So we add the two probabilities here. So that's 16 over 40 plus 9 over 40. And what is the LCM? The LCM is 40. And you have 16 plus 9 is equal to 25. So you have 25 over 40. Reducing it to lowest term, which you have is 5 over 8.